Scarabs were the most common form of stem cells in the southern Levant during the 2nd millennium BCE. They are shaped in the form of a dung beetle, a symbol loaded with meanings for the ancient Egyptians. Originating in Egypt, they were first imported to the southern Levant and soon after were locally produced. Previous studies dealing with scarabs focused on their typological classification and their iconography. In our study presented here, we focused on the production of scarabs according to the theory of chaîne opératoire, a methodological tool that analyzes technological procedure into different sequential phases, from the procurement of the material until the finished object. The reconstruction is primarily based on the study of scarabs found in archaeological sites in and around modern-day Tel Aviv, visual representations of seal and bead production from ancient Egypt, and results of previous experiments. The main goal of this experiment was to verify whether the reconstructed production sequence fits the scarabs in the corpus and how the work with steatite was executed. An additional goal was pedagogic, to teach the basics of experimental archaeology and provide MA students at Tel Aviv University with practical experience. Most scarabs were made from steatite, a soft talc schist, an easily shaped stone. This is why we decided to focus on the production of scarabs from steatite. Steatite was quarried in Egypt and transferred to the southern Levant either in blocks or as semi-finished items. Like ancient Levantines, we also purchased our steatite from a local store specializing in semi-precious stones. We started our work by creating roughouts, small blocks of 3 cm long, 2 cm wide, and 1.5 cm thick. We used flint tools such as blades, retouch blades, and backed knives. The decision to use flint tools was based on archaeological finds from the 2nd millennium BCE sites in the southern Levant. Drilling was conducted using a bow. For this phase, we used borers made of 5 different materials: flint, bronze, copper, bone, and wood. Bronze and flint borers were found in various assemblages in this period in the Levant, while the other materials were accessible during that period and were chosen by us to create experimental variability. In the next phase, shaping the features of the beetle, we used materials with a rough surface, such as basalt, flint pebbles with cortex, and a local sandstone, as well as flint tools. Polishing was made with shell, hide, and wood. The next phase was engraving of several chosen motifs, which was executed using flint, bronze, and copper tools, and added a natural material, a porcupine quill. 15 students participated in our multi-stage experiment. Therefore, we followed protocols that accompanied the experiment and prompt high level of observation of the different experimental lines. In addition, we followed an item protocol that included all steps of the work, working tools, and a description of the scarab itself. The experiment showed that drilling in steatite is a crucial and complicated phase, with a high risk of breaking the seal. Therefore, it is likely that this phase was executed as early as possible and by experts. Moreover, drilling with a bow requires preparation, a minor fault which was executed with a flint borer. In our view, the most efficient material for drilling in steatite is bronze. The experiment provides a basic confirmation of the reconstructed chaîne opératoire. Our next goal is to perform a use-wear analysis of the tools and 3D scannings of the produced scarabs that will be compared to the original scarabs. The result of the experiment raised some unanswered questions related to the glazing and firing techniques and their location in the sequence of production that will be addressed in future experiments.